Okay, so I'll just take
He
that
was
as a
just
yes.
leaving at that
Okay,
age. And it was
so
just so
right here we're gonna
inspiring.
be
It's great. Clarity. And I didn't follow him back. What the hell?
all right. So we are back. So this is the preparation for the incoming test tomorrow for MATH141, right? Okay, so we're gonna start with the basics, right? So these preparation right of here, I don't have the examples because that would be not effective. If I throw all the examples, maybe the problem is going to be a lot of problems out there, and then tutorial problems as well. And then after that, at the end of the day, you don't know what you're going to find on the test, right? So it's better to start with the basics. So I'm just going to be covering the area, the volumes, arc length, and all that, and what else? uh, parameterize curves and then verifying the solution. I think that's 7.2. And then all the way to 7.3, I guess, separable differential equations. And then after that, you'll be done. So it's just going to be a pretty short session. And then after that, you're going to go back and start on the domes. All right. So I'm just going to be explaining the basics. All right. So we start with the area, we'll wrap it up. Okay. So when finding the area, all right. So I'm just going to try to be slow. If I am fast, please stop me. All right. So when finding the area, we're going to stick to the basics. All right. There's a question. Okay. Is my screen still black? Okay. All right. So we're just going to have to carry on. Right. Okay. There's another question. Okay. No. All right. Thank you. All right. So about the area, good people. So what I usually taught students about the preparation, we're not going to be throwing the equation, but is to understand the procedure, right? Because the mistake they will make, the tutors and the SI leaders, they'll be like, okay, you know how to solve this problem. But how can you solve each and every problem under that topic? Okay, that is what I'm going to do. Okay. So now about the area is the same steps, it's the same rules. Okay. So you say top minus the bottom, right? So at first, you're going to be given the two curves. All right. So how do you find the error between those two curves? So you look at your curves, right? Which one is on the top? Which one's on the bottom? Then after that, do the work. And then after that, if maybe you have something that is on the right and another curve on the left, so what you have to do, right minus left. So now there is a thing, okay, I guess it's right here, right? So that's the basic rule. I guess you know that, right? It's pretty easy. Okay. So now, if you're not sure which one is on the top, which one's on the bottom, which one's on the right, which one's on the left. So what you have to do, actually, you have to draw the vertical line. So if you want to find which one's on the top, draw a vertical line, starting at the top. The one that's going to cross the curve first is just going to be the one at the top. The one's going to cross the line first, actually. And then it's the same thing, draw a line, a horizontal line to find the one on the right. That's just pretty simple as that. Okay, so now the only thing that will trick you is the boundaries. If you don't have the boundaries, because the thing that you're gonna do, they're gonna give you the equations of the curves, right? That you have two curves. Then after that, you don't have the bounds. So the only thing that you have to do, the first step, is to find those bounds. Okay. So you set equations equal to each other, and then after that, you solve to find the interactions. Those intercept actually interactions, whatever. I don't know why I just say that. Okay, but you're just gonna have to find the bounds. So when you equate those equations, you're just gonna find those bounds. Okay. So now, if you don't know how to draw the curve, this is the thing that I usually tell students. Maybe when you're working with the method, this one probably, the one you say top, mud at the bottom. So if you don't know how to draw the curve, because some of the time they're gonna give you complex curves, but not always. Okay. So the first thing that you have to do is to plug in the values that are inside the bound. Okay. So, and then after that, you will have to compare. Right, how do you do that? I'm just going to do a quick example right here. So let us say we have what? Maybe y is equal to 3x, and then we have y is equal to what? Maybe x squared. Okay, these are the two curves that we have. How can I draw these curves? I don't know how to draw them. Let's say I don't know how to draw these curves. Now, how can I see which one's on the top and which one's on the bottom? Because right over here on the area, we say f at x, that's the one at the top, and then g at x, that's the one at the bottom. Because the only thing I need is my integral. Okay, how can I compute my integral so that I'm going to solve? I have to find the one at the top and the one at the bottom. All right, so in this case, if we can just quickly draw this to verify that, we're just going to have x squared. Okay, we're looking at this portion, and then you're going to have 3x, all right? That's just a straight line. So the interval is take 0 all the way to 2, right? So now we're going to plug in the values that are inside the bound, okay? So the value is going to be 0, but right over here is just going to be 0 everything. As you can see right over here, everything is 0. Okay, let's just plug in 1. So if you plug in 1 right here, y is equal to 3 at 1, that's just going to be 3, okay? And then y is equal to 1 squared, that's just going to be 1. So you see right over here that this linear curve is on the top because it is greater, right? The one that is greater is on the top, and the one that is smaller is on the bottom. So this one is got a 1. Even if you can plug in 2, right? You plug in 2 right there, you're going to get a 6. Okay? You plug in 2 right there, 2 squared, that's just going to 2 to the power 2, that's just going to be 4. So right up here, you can see right that 6 and 4, the 6 is greater, right? So which means this 3x is on the top, and then this x squared is on the bottom, right? If you didn't know how to draw that. So that's what you have to do in other problems if you don't know how to draw it. Okay. So let us move on. I guess that's it for the area. It's just pretty simple. Those are the basic steps that you have to understand. Right. About the volumes. Now, the only thing that we are trying to find here is an integral. Okay? Nothing else. Integral, then after that we solve. Now, right over here we got the volumes. The first one is a disk. Think of a disk. Okay? If you have a disk method, think of a disk. Okay, what is a disk? Disk look like this. Right. So now I have to decline that. Is that important? No, that's not important. Okay, so you will have a circle, right? So that's a disk. Now ask yourself, if we want to find the volume, we need to integrate the area, right? So what is the area of the circle? Is just pi r squared. Okay, so the radius is just your radius, right, of that circle. So right over here, I just made an equation of an area only, not the equation of the volume. Because right over here, the only thing that you have to do is to integrate your area. Okay. Right. So you will have to integrate your area. So on the equations on the book, you will see, you find that it's going to be pi f at x, right, squared, right, f at x squared. Now that's not a problem. I'm using r, the radius, because it's not gonna put you down, because some other time f at x is gonna put you down. So right over here, look at the area. Okay, look at the radius. So you start from the center and then all the way to the surface. So what is your surface? Your surface is your function, is your curve. It's just the fact that it has been revolved around, but that is your curve. So they will put f at x right there, but I'm putting the radius, okay, because the radius in this case is just your function, right? It's just your curve. But now, the where it becomes a little bit complicated about this f at x, it is when maybe probably we revolve it about the line, maybe y is equals to -1, and then it will become a problem, right? Because at the end of the day, we have to look at the total area, the total radius, sorry. Okay, so that's it about the disk, all right? You're just memorizing everything. Okay, what about the washer? Think of a washer. If you have a washer, we probably need this, this thing right over here inside. You probably need that thing inside. It has a hole. The washer has a hole. So right over here, in order to find the radius of this part, right? So you see right over here that on your washer, you've got your outer radius as well as your inner radius. Okay, fine. Now, what is the area, okay, of the part that I want? So in this case, the area is going to be pi because that's going to be your circle, right? So now, this outer radius r squared is your outer radius, right? Outer radius minus the inner radius to get that thing in blue, right? That's the thing that I want. That's the part that I want in blue because I don't need the inside part because it is hollow. There's nothing on the inside. So I would have to say the bigger r minus the smaller r, okay? Okay, fine. Going back to that f at x, I'm just going to keep on relating to that. If you can look at this circle, right? They have been revolved, right? So these are the curves. So which means this is your top curve, and then this is the bottom curve, right? If you can look at this, the outer radius is just the one from the center all the way to the top, right? All the way to the surface. Now that's going to be your f at x, the one at the top. So you will have your f at x right here minus the bottom, which is going to be your g at x. Okay, I hope you get that one. So right over here, I'm just summarizing everything, the formulas. I'm not going to throw the equations. Right. So cylindrical shell. So about the cylindrical shell, so think of a cylindrical shell, okay? So you think of a cylindrical shell, and then after that you cut it vertically, okay? So when you cut it vertically, the only thing that you need is the rectangle, this rectangle, because the volume is going to be equal to 2 pi multiplied by the radius multiplied by the height. Okay, fine. Now, what is my radius? Okay, we start from the center all the way to that rectangle. Okay, from the center all the way to that rectangle. So that will be your radius. Okay, and then the height is just going to be that height. Okay, that's the only thing that you need is the radius and then the height. That's the rectangle that you need. So a clear common example right over here, you have this, right? So you revolve this about y. Okay, so you'll have to draw a rectangle right here like this. And then your r, your radius, is just going to be from the center all the way to the radius. That's going to be your r. Okay, then what is your r in this case? It's just going to be your x. That's going to be your x. And then what about the height? It's going to be 0. It's going to be the top, not 0. It's going to be top minus the bottom. So the top is your curve, which is square root of x. So that's just going to be the square root of x minus 0. So in this case, you're just going to have the square root of x. So that's what you're going to have. Okay. So on the cylindrical shells, you just need a rectangle. And then after that, find your radius, multiply by the height. Don't forget the 2 pi. Okay. So let us move on to the arc length. Nothing authentic about the arc length. The thing that you have to remember is the procedure, right? The first thing that you have to do when you want to find the arc length, just find the derivative of the curve that you're given, okay? You have the equation, then after that, find the derivative, okay? Then once you have found the derivative, the only thing that would work if you want to compute that, you will have to use the use substitute because right here you have a square root, okay, of 1 plus that curve, right? The only thing that's going to help you is the use substitution. Then the square root is going to be your curve. So which means everything inside the square root is going to be your u. Sometimes it not may work, but it's going to be a u. Okay, so the arc length is pretty easy, good people. You just have to find the derivative of what you're given. Then after that, plug in everything. Okay, let us move on to the area of surface of revolution. Right. So the reason why I'm doing this summary is because I want to highlight the most important part. That we've got example right here. Okay, the area of surface of revolution. So about the area of the surface, okay, so you will have to add the arc length equation, okay? Then the rest you have to 2 pi multiplied by the radius. Okay, but now the step that you have to do in order to solve each and every problem on the area of surface of revolution, so in that case, you'll have to find the derivative first because that will be your master, right? Find the derivative. Then after that, you use a use substitution since you have the square root. Okay, so find that, and then after that, you're going to have to compute your surface area. Okay, we've got examples right over here. These are pretty hard examples from the past question paper. I think it's 2008. Okay, I just saw it on the grind. I don't know whether it's there or not. Okay, so we've got example right here. So I've just picked the most tricky questions, not the easy ones. Okay, because I don't want to waste your time. Okay, example, y is equal to e to the power x to the power 2. Now we have y is equal to 0, y is equal to 4, revolved about the y-axis. We need to determine the volume. We need to find the volume. Now, it doesn't matter what method you use because I didn't specify that. So use any method. But now, the most important and easy method is this method. It's just pretty simple. Okay, you need to find the radius. That's all. Now, if we can look at this, right? Let us say you don't know how to draw this. Okay. So if you don't know how to draw this, it's not a problem. Okay. But now the thing that you have to do is to find the radius. Okay. So finding the radius, that's going to be a little bit tricky, but it's not going to be tricky. Okay. So in this case, the method that I often use, if you can just blend in that E, you look at x squared. What is the x squared look like? The shape. It's your parabola, right? So which means you're just going to have a parabola. But now let us come down to this. Okay. So the reason why I have a 1 right there, it is because this y is equal to e to the power x squared doesn't have an x-intercept. Okay? I think you've realized that. So if you plug in a 0 right here, okay, let me just draw that. If you plug in a 0 right here and solve for x, you will have to apply ln on both sides. So ln of 0 is something else. Okay? It's a human error. The calculator will tell it's a human error. Please stop that. Okay? So it's just going to be a human error, which means that there are no x-intercepts. But now when you plug in 1, well, probably you would get a 0. So that is why right over here we start at 1 and then it goes up. Okay, so which means right over here, this is not going to work when you're computing your antiderivative. The lower bound is not going to be 0, but it's going to be 1 because it's going to start at 1. All right, so the mistake right over here that you will often do when you try to solve this, right, is solve for x in this case. So you multiply by ln on both sides, right? That's cool. And then after that, bringing down the exponents. Okay, so you'll have to bring everything that is on the top of e, right? So in that case, it is going to be x squared, right? So you have to bring down that x squared, not 2, like what I did right here, okay? So not that 2, and then you leave the extra out of there, but the whole thing, okay? So at the end of the day, you will have ln of y equal to x squared ln of e. So ln of e is going to be 1. You solve for x, you're going to get a square root of ln y. Okay, so now the area is just going to be equals to, so now the equation that I have, because we revolve this about the y-axis, right, which means the substitute of the formula is going to be x. Now, remember that we said that, okay, when finding the volume, right, pi of r, so that's going to be a function, right? That's going to be a curve. Now, in this case, my curve is this. So that's going to be my r. If we didn't draw that, so that's going to be your r. So as you can see right over here, pi of r. My r is my function, which is f at x. So my f at x is the square root of ln y squared. And then that is going to be the area that I'm working with. Okay. Then after that, you're just going to have to integrate that. But if you are a master, you should try to draw these. You can see right over here that your radius is just going to be your x. So in this case, what is your x if we have this? You will have to solve for x. And then when you solve for x, you're going to come back to this thing, ln of y, square root of ln of y. Then after that, you will have to solve that. Okay. So these are the two methods that I just explained, that if you didn't draw that, remember that it's going to be your r, the radius. What is the radius? It's going to be your function, your curve. Okay. So now after that, you just have to, okay, so right over here, there's another important thing, IBP. Okay, the reason why I picked this problem because it is very tricky. Okay, so what is an antiderivative of ln y? The antiderivative of ln y is not going to be easy, but it is y ln y minus y. Actually, probably right over here, I just used the IBP method. Okay, the integration by part. Use the integration by parts in this method. After that, you're going to be good to go. Okay, this was pretty hard, but it's not that hard if you know what is an antiderivative of ln y. Then you're going to get that. Okay, if you didn't know, use the integration by part. It's going to be easy. Okay, we'll look at the arc length of this. Right, so what is the arc length of that? Now, this is the most important section that I want you to pay close attention to. Okay, so if you're not listening, please pay close attention. Remember from 1 through 1, okay, maths 1 through 1, I explained something that you didn't catch, but others they did. Okay, right over here, if you are given a curve and then you want to find an arc length, so you need to find the derivative. We all know that, right? You take the derivative of what you're given, then after that, you're good to go. But now, in this case, they gave you the definite integral. How can you find the derivative of the definite integral? This is the definite integral that we are given instead of a curve, just a simple equation, but it's a definite integral. Now, back from MATH141, you'll have to remember that, okay, the derivative of an antiderivative is just going to be back to your function, right? It's just going to be your function. Okay, so in this case, since right over here, I'm just going to hash out on that. I'm not going to go back to that concept, right? So I'm just going to hash out on top. So right over here, since we have x, so it's just linear. We don't have a parabola. We don't have a cube. So right over here, we have x. So the only thing that will change, instead of t, we're going to substitute x. And then that's going to be the derivative. So y prime is going to be equals to the square root, the same thing, square root of 1 plus 4x squared divided by 1 minus 4x squared. That's the derivative of the definite integral that you were given. Okay, is to use the method that I taught you from MATH141. Okay, so because right over here we just have x, not x squared. If it is x squared, it's just going to be quite different. About these two, do not worry about it because the derivative of the constant is just going to be 0. So at the end of the day, you're just going to have this. Okay, that's the only thing that you have to remember. So yeah. So the arc length is going to be the derivative of what you were given. So what are we given is a definite integral. The derivative of the definite integral, it is that. You take that, you put it back here. Okay, that's going to be the derivative of what we are given. And then after that, you will have to solve your complex fraction inside. So solving for the complex fraction, at the end of the day, you're going to stop here. Okay, because right here, you will see that you will have 1 divided by the square root of 1 minus 4x squared, not 4x. Now, if you try to use the u substitution at this point, okay, you will say maybe your u is going to be everything that is inside the square root, right? That's not a problem. But when you derive these, you're going to get what? Negative x. What is happening? If you have two variables on the bounds, on the boundaries. Okay, it's the same process. Okay, I guess you still have the nodes for the derivative of the definite integral from S131. I guess you will have to look at that, but it's the same procedure, right? So when you're deriving this, so at first you just have to make that complex thing as your f at x, right? So that's your f at t. And then after that, you have to take the definite integral as if you are just computing the the derivative not working with the bounds, but working with n b. And then after that, at the end of the day, you would have to substitute everything. But you will have to look at that. Okay. There's a question. Okay. So about 1 and 4, 0 and 1 over 4. So right over here, since right here at this point, you have to do the definite integral, right? And then the arc length from 0 to 1 over 4, that should be your boundaries. That's an interval that you're given. Okay. So right over here, the trick that you're going to get, they started from 0 all the way to x. In this point, they just wanted you to find the derivative. You got tricked. You were going to use 2 and x, which is wrong because they gave you the bounds, okay, which is from 0 all the way to 1 over 4, right? So that's just a sign that you will have to change this whole thing and then find the derivative only, just the derivative, so that you're going to come and substitute it right here on the equation, and then after that, substitute your bounds, not this bound that you're given, because that's the definite integral that we are given. Finding the derivative is going to change everything. We're going to lose the bounds. We need to find the new bounds we are given. Do you understand that? Okay. So let us move on. So right here, I was just explaining that you have 1. If you derive this, try to derive, because if you make u, that whole thing, you're going to get your 8x, right? It's going to be 8x. Now, in this case, there's no other x that you're going to cancel out with your integral, right? So it's not going to work. Even if you can make your u to be x squared, it's not going to work. You still have a square root. Now, remember from your table, right? So an antiderivative of 1 divided by that, just going to be your arc sine, okay, of half an angle that you have. So right over here, we have 4. We need to halve that is going to be 2. And then x squared, we just have to find our 2x right over here inside. So you'll have to know this. Probably they're not going to tell, but you'll have to know this. So yeah, test 1 of 2008 was pretty hard. Probably, yeah, a lot of people failed it. Okay, so that's the basic setup of this because this is quite complex. Please go back to it and understand what is happening here. Okay, you're not giving the curve, but you're giving a definite integral. Find the derivative. You're going to lose the bound that you're given from the first place, and then find your new bounds. What are your new bounds from 0 to 1 over 4? Then you have to substitute that. And then what is happening here? Parametrized curves. Okay, you need to find the area of a surface. Right. Okay. We've got two curves right over here. So now I want you to remember this. Let me just go back to the equation, right? So as you can see right over here, the area of the surface, we just have to find the derivative of the first curve, right? So we need to find the derivative of it. Just you're going to be given a curve and then find the derivative of it. Now, the thing is, on this problem, we are given two curves. How on earth can we do that? Okay, this is parametrized curve. Okay, so the way to do this is just the same thing, but right over here, you're not going to have 1, but you're going to have the derivative of the first curve. Then that's going to be the derivative of the second curve. Okay, I want to vote, right? Shall we do this problem or not? Okay, I'm just going to explain right over here, but it's going to be something like this. Okay, so we're going to have the surface is going to be equals, it's just the fact that I don't like to write, but the surface is going to be equals in order to solve this because you're given two curves, right? That is your bounds, right? Those are your bounds. And then revolve about the y-axis. So now, at this point, since we know that finding the area of a surface, we need just one curve so that we're going to substitute in the equation. But now we've got two. How can you do that? So the surface is going to be equals to 2 pi, right? It's going to be 2 pi. It's the same thing, right? Inside derivative, then the bounds from 0 all the way to pi divided by 12. Okay, that's horrible. Pi divided by 12, and then after that, E is going to be your first curve at t. That's the one right there. Okay, that's going to be your x at t because this is the function of time. It's a function of t, not time. Okay, there's a question if I move on. All right, so I'm going to go back to that when I'm done with this. Okay, so now that's the square root, and then we're going to have to find the derivative of the first curve that you're given, right? Square that plus the derivative of the second curve that you're given. So that's going to be y at t, y prime at t squared. This is what you're going to have to do, dt. That's the equation that you will need, okay? Because right over here, the trick is that you are given two equations, not one, okay? But you know exactly that instead of this right over here, you just have to need one plus the derivative of a curve that you're given. But now there are two. In order to do that, it's the same procedure, but now you will have to start with your x at t because that's going to be your r actually when you revolve that about the y-axis. And then the square root of the derivative of the first curve plus the derivative of the second curve. Then after that, you'll have to carry on and solve that. Okay. So let me go back to the question on the chat. Right. So before we move on to the verifying the solution, which is pretty easy. Okay. So right over here, you're going to find this on the table. All right. So the antiderivative of that, you're going to find it on the table. Right. Check it on the table. I guess you'll have to see that. Okay. If we had 9 right there, we're just going to have a 9 right there, not 2. And then you're going to have a 3 right there. Okay. So if you had 9x squared, you're going to have 3 and 3x right here. Okay. Since we have 4, we're going to have a 2 and a 2. Okay. So it's just going to be like that. Okay. Let us look at verifying the solution. Now, this is 7.2 on the Thomas calculus, right? So verifying the solution is just pretty easy. So when trying to verify the solution, okay, there's a question. Okay, so the exponential growth is under 7.2 and 7.3. 7.3, I guess, is going to be your what? Uh, What functions, hyperbolic functions. All right, so you'll have to know that. But I didn't cover that here because that's just a concept, okay? These are the problems that we need. Okay, we've got 2 pages to go. Okay, but if you need that concept, actually, I guess you'll have to know it, right? It's the application, actually. Okay, so verifying the solution, right, on 7.2, this is the first problem. Actually, I think it's number three. Okay, exercise 3. So at this problem, you are given y is equals to that. This is what you're given. I want you to understand the basic layout, how to solve each and every problems. Okay, so let me come down to this part. Okay, this here. The initial value problem, okay? So it's just a part of a differential equation. So here you would give in the function and on that function a derivative, okay? You'll be given an initial equation as well as the solution of the candidate. All right, the solution candidate. So the initial equation, it is when you will be given that, okay, why something is going to be equal to this, okay? You'll be given the value. But now let's come down to this, okay? Verifying the solution is pretty easy. The only thing that you have to do, look at what you're given, okay? So what am I given right over here? We're given that, okay? This is what am I given. So at the end of the day, I will have to say x squared multiplied by y prime plus xy, is it equals to e to the power x or not? Okay, so this is what I am trying to work with. Okay, and then at the end of the day, if I plus that, if I take the sum of that on my problem, is it going to be equal to e to the power x or not? Okay, that's what you need. Now, at this point, if you are given the equation, right, the first thing that you have to do is to derive, okay? I'll have to derive that. Now, when you derive this, be careful, okay? You need to be careful because there's a definite integral, okay? So now, when you derive this, okay, so I guess you'll have to use the product rule because these are just two separate, okay, different equations, right? So we have 1 over x, right? What's the derivative of 1 over x? It's just going to be negative 1 over x squared multiplied by what is already there. Okay, that's not a problem. Plus the first part, I don't derive it, multiplied by the derivative of the second part. Now the derivative of the second part, as I've told you, the derivative of the definite integral. Okay, in this case, we have x, which is linear. Go back to your 131. In this case, we're just going to have our x squared divided by x. Okay, so the only thing that you have to do is instead of t, we're going to substitute x. Pretty simple as that. Okay, instead of t, we're going to substitute x. This is what you're going to have. Okay, fine. The next step, what do we do? At this point, okay, we sum up that. Okay, we're going to have x squared at the bottom. Okay, you see that. There's going to be x squared at the bottom. Now, since I have x squared on this point, and I have y prime, because the only thing that I need is my x squared multiplied by my y, right? My y prime. So I need that expression. So I'll have to multiply by x squared everywhere, okay? So when you multiply by x squared everywhere, you're going to get this first part, which is that what I need, right? It's going to be equals to, this is going to cancel out. You're going to be left with negative of that plus e to the power x. Now, this is your x squared plus y prime. Okay, check. I've got that. Now, what is the second part? Is my x multiplied by my y. Okay, how can I find that? Okay, go back to your equation, right? So right over here, it's just pretty easy. We have 1 over x here, we have x here. How can I just compute that to look like that? Just multiply by x, right? So when you multiply it by x, you're going to have xy equal to the definite integral from 1 to x of that, okay? Now, the only thing that is left is to combine everything, right? Because I've got the first part, which is this part. I've got the second part, which is this part. When I plus it, okay, is it going to be equals to e to the power x or not? Okay, so right, when you plus that, you will see that it's going to cancel out. These integrals are going to cancel out because we've got negative and we've got positive. Now, the only thing that's going to left is your e to the power x, which is equals to the thing that you were trying to verify, that e to the power x. It's just pretty simple as that. The first thing that you have to do, the derivative, and then after that, do everything to find what you need. And then find the sum. After that, you will have to compute and find the answer. Okay, so that's when you're verifying the solution, right? You're just verifying the solution by using what you have. Okay, but keep an eye on the derivative of the definite integral. Okay, so right over here, this is problem number 7, exercise 7 from our tutorials, right? So we have x multiplied by y prime plus y, okay, is equal to negative sign. The thing that I need, remember this, good people, always remember that I'm given this, okay? This is my condition, right? So x multiplied by y prime plus y, is it going to be equal to negative sine x or not? Okay, so on my equation, everything that I have, I need to find my x multiplied by y prime as well as my y. And at the end of the day, I'll have to sum up that and then see whether is it equal to negative sine x or not. Okay, so the equation that I have, this is the solution candidate, right? So y is equal to cos of x divided by x. This is pretty easy. The first step is to find the derivative. Now, when you find the derivative, right over here, you have to use a quotient rule. Okay, so find the derivative, use a quotient rule. And then after that, this is my y prime. I've got my y prime right there. Okay, so now, how can I have my x multiplied by y prime? So it's just pretty easy. Just take that, and then after that, if you cannot compute it from the equation, just take it on the equation, right, that you're given, right? So right over here, x multiplied by y prime. So right over here, I'm just going to do that. I'm just going to say x instead of y prime. I'm going to substitute what I found, okay? So my y prime right over here, this is my y prime, okay? So I'm just going to substitute it on this equation. So I'm going to have x, that's going to be my x. Y prime is going to be something that I have found, okay? And then after that, plus y. What is my y from the equation that I had? That is my y. Okay, so now take a look at this. The only thing that you have to do is to find the sum of this. At the end of the day, you must find your negative sine of x, okay? At the end of the day, you must get your negative sine of x, okay? So computing this, okay, we have less than 1 minute, right? I guess we only have one page left. Okay, all right. So when computing this, at the end of the day, you will find your negative sine of x, which is equal to the thing that they wanted us to just show. This is negative sine of x. And then you also find negative sine of x, which is approved. And then right over here, we just have to substitute pi by 2 and check whether it's equal to 0 or not. So on your y, substitute pi by 2 right here. So probably just going to be cos of pi by 2 is going to be 0. 0 divided by any number is just going to be 0. So that's what you're going to have, which goes along with the equation that we had, that y of pi by 2 is equal to 0. You have to double check that. You're going to get